just one of the ice giant planets in our solar system, and it's just located after the Saturn and before the Neptune. However, this planet is one of the most unique planets in our solar system. It has too many questions, too many irregular features, which we'll discuss in this video. Probably if you are not an astronomer, you will not know much about the Uranus, apart from the funny name. We know it's the ice giant, it's far away, and it's a beautiful color. What actually we do know about Uranus, why it has these particular properties, and why it's unique, let's talk about it in this video. The first unique thing about this planet is that it's been the first one that been discovered using the telescopes. A long time ago, in 1781, William Herschel discovered it. Previously, people observed it, and you can observe it today with the naked eye, but it will look like a very faint star. Herschel thought it was a star as well, or he was thinking it's some kind of comet. He also described it as a comet. Careful studies show the movement of this planet, and scientists concluded that it must be a planet. That we understood first time the size of our solar system, not as we expected before. It's much bigger. At that time, this unique name was given to this planet, Uranus, and it wasn't given straight away. There was a debate. Somebody suggested to continue the sequence of the Roman gods and call this planet Neptune. However, we know it didn't happen. The next planet was discovered and called the Neptune, though. Somebody suggested to call this planet after the Herschel himself. After the long discussions, the science community decided to call it Uranus after the Greek god, and it's for today the only planet in our solar system named after the Greek god. Therefore, if you are confused how to call this planet Uranus or Uranus, apparently in the science world both names are accepted today. Despite its unique properties and amazing discovery, this planet not very well studied. Only once we have a flyby of Voyager 2 in 1986 was the time when we have some exploration of it, have close images of this planet and its satellites. Therefore, we don't know much about this planet. Until the telescope observation in the past few decades, we thought it's all a rather bland planet, dark, cold, slow, and with few interesting features. Recent data, especially in the last 30 years, even the remote studies showing a lot of new information about this planet now. So what do we know about this planet for today? Well, first of all, this is the ice giant. And the ice giants, as we know, planets that are located in the furthest part of our solar system, mostly composed of gases. And for your surprise, you would think that Uranus or a Neptune have a fully gas features inside. However, scientists suggested that Uranus must have a solid silicate rock core inside. However, there is still no surface on this planet, so there's no like on our planet you could standing on the surface of it and looking through the atmosphere into the space. No, that's not happening there. There's a thick atmosphere which kind of getting into the compacted, condensed gases, so you will not could find the surface which you can actually stand on. So it's the third largest planet, radius, and it's fourth largest by mass. And it's about 19 astronomical units away from the Sun. It means it's 19 times further than our planet. Uranus is a gas giant, and along with the Jupiter, Saturn, and Neptune, and many suggested that Neptune, it's kind of like a twin of this planet. But Uranus is the least massive of the four. However, it's 14 times more massive than our planet, Earth. Uranus' diameter 4 times larger than of Earth, and one unique feature it has is this the coldest planet in our solar system. You would think, hang on, the Neptune is further away, and this ice giant too. Shouldn't be colder there. Recent data say that average temperature on the Uranus is freezing, about minus 200 degrees Celsius on average, going as cold as 224 Celsius degrees in particular cold places. Why it's like that? We're not sure about that for now. However, one of the suggestions is something doing with the atmosphere of the Uranus and the way that the heat distributed, and that's the heat from the core of this planet doesn't coming through towards the surface, doesn't warm it up. Many suggested the physical properties of this planet, the way it's rotating around our sun, could cause this strange climate on this planet. So that's where we come to the next unique feature of this planet. It's the way it rotates and its tilt. So it's not like any other planet in our solar system, which are tilted slightly, more or less. They're all perpendicular to axis of our sun. Uranus has 97.7 degree axial tilt, and it means that it's parallel with the plane of the solar system. It poles are on the other side. If it's hard to imagine for yourself, so if you look on our Earth rotating around the sun, it moves around it, and most of the time the equator is always in the middle, and the poles, top and bottom, one by one, exposed to the sun, depends on the time of the year. For the Uranus, it's like a ball rolling towards sun and away around it, and with the poles lying on the side. It will mean that, for example, south pole of this planet, half of the year will be facing towards the sun and half of the year will be facing away of the sun. And the equator will be exposed to the sun very rarely. So you can imagine it means that there's a very strange weather patterns on this planet. Why it has such unusual tilt? One of the suggestions is, of course, planet must be experienced a large collision with a big planet, maybe of the size of our Earth, in the beginning of the formation of the planet. So in the first billion of the years of the life of Uranus, it smashed it from its normal, like everybody, like all the planets on the solar system, tilt, and it caused this rolling like that position. So it's just basically smashed, collide, chipped off the pieces of this planet, forming numerous moons, which we talked about, satellites of this planet. Poles, instead of being north and south like for the Earth, they just rotated almost 95 degrees. Therefore, this tilt impacted everything about this planet. Extreme seasons and weather fluctuations. And its magnetosphere is tilted and asymmetric. The ring system of this planet, which we'll discover later, it's on the side too and comes close to rivaling Saturn's in complexity, recorded about 27 moons, and the rings, about 13 rings around this planet, which are as well tilted in a similar way, and very irregular moons and rings as well. Another interesting unique properties of this planet, its structure, its composition. So it's a gas giant, as we know, or some call it ice giant, and it actually has a core of silicate rock, as study suggested, which encased in ices and topped with a gaseous layer. The core suggested to be quite small, and since Uranus is the second least dense planet, and the actual gravity on this planet slightly less than for the Earth, therefore you might find quite comfortable there. So the ice mantle surrounding the core is fluid, with volatiles like methane, ammonia, and water. And we call it ammonia water ocean. And the outer layer, as for the most of the gas giants, is mostly helium and hydrogen. Some suggested that in this ocean there's a particular condition that methane releases a lot of carbon, and under the pressure this carbon formed numerous diamond particles which saturated, and they kind of floating in this ocean. And imagine there's like a rain of rocks which are actually diamonds happening there. We're not sure if it's true or not, but you can imagine the planet inside of which is diamonds rather than just a molten silicon rock like we have on our planet. That's making this planet another jewel of our solar system in direct meaning. So the collision of this planet with the big body in the beginning of its formation could cause from this collision losing a lot of heat, and the planet since then stayed colder. For example, in comparison with the Neptune, we find that the Neptune radiates 2.5 more times heat than the Uranus, so it means this planet is pretty cold. The atmosphere is layered, and this have thermosphere, stratosphere, and troposphere. The lower layer, troposphere, is interesting, rich in volatiles iced like methane and ammonia. And we observe the clouds there: methane, hydrogen, sulfide, and ammonia, ammonium, hydrosulfides, and the water clouds at the upper limits. However, when we looked on this planet today with the better telescopes, we can a little bit better observe it. We should keep in mind that we didn't see the whole year cycle of this planet, because the planet rotates around the Sun in 84 years. Therefore, we cannot tell much about its climate and the clouds' behavior, yet we only have a partial observation for today. But we do observe some changes. Uranus tends to look light bluish or greenish in the color and have darker bands. And this is because methane absorbs visible and near infrared light like that in this spectrum. After the Voyager trip in 1986, basically it was passing through Uranus and the Neptune as well, and send us pictures back. However, the Voyager is still traveling on its destination. Its probe found a bright polar cap at the South Pole, as well as a lighter band called a collar. And there were darker bands in the southern hemisphere and about 10 lighter clouds around the middle latitudes. That time the Voyager couldn't observe the northern hemisphere, it was in the dark. The Hubble and other ground-based telescopes study the atmosphere of Uranus since the 90s as well, and they spotted more clouds in the northern hemisphere, which are brighter and at the high elevation than the one in the southern hemisphere. And they also observed in 2007 that the southern color had nearly disappeared while one in the north had grown. So that could indicate on some kind of seasonal changes of the atmosphere on this planet. And a unique magnetic field is characteristical for the Uranus as well, and for the Neptune too, and we'll talk about this in the video about the Neptune. So what's a magnetic field? All the planets have a magnetic field, a very faint one, or disappeared one, or current strong one. And it's usually produced by the material inside of the planet, the core, outer core, or mantle, which create this electromagnetic field around it. And it's actually protect the planet from destructive radiation from the sun. However, the magnetic axis for this magnetic field is well unusual, and it's tilted 59 degrees from its rotation axis. And a very unique thing about the magnetic field of this planet is that this magnetic center is not in the middle of the planet. It's displaced about 8,000 kilometers. Many suggested this is another evidence of this collision of this planet, the beginning of its formation, which kind of changed the center of this magnetic field. And also the interesting that its magnetic field kind of smeared around the space and have very long tail corking into the space. It sounds very interesting, and it can indicate on the history of this planet, its formation, and what happened with this planet. It also may indicate on the future what might happen with this planet, how the gas giants formed and what the evolution of these planets. And let's talk about interesting part about the moons and rings of this planet. Yes, Uranus, despite that on the pictures it looks kind of boring, nothing happening, has a lot of moons and rings. not as distinct as a Saturn, which you might even see with a very weak telescope or binoculars. Uranus, with the average strength telescope or binoculars, you might observe some of the rings, but they're not as straightforward. When you actually look on the Uranus in a telescope, I haven't the pleasure to observe it myself, you will see not like for example for Jupiter, the planets going around and the moons going around it and the rings kind of like on the equator, they're sitting horizontal. On the Uranus, the rings will go all around, so you'll see actual circles around the planet, which are the rings and the moons. But that's make it harder to observe. So when the planet was just discovered, Herschel suggested that he saw the faint ring around the planet. However, scientists think it's probably unlikely at that time he could see that. The ring system was officially discovered by a team working with the Kuiper Airborne Observatory in 1977 and 1978. They find total 9 rings around Uranus. The rings were observed first by watching the star. There was distant star was passing at the background of the Uranus, and you can see the distortion from the rings or the moons. And they noticed this, that the star went dim for a few minutes before Uranus appeared. It was the first evidence of the ring. And it was confirmed later by the Voyager too. He photographed it nicely for us, and we have good images, and even of some moons as well. For today, we know that Uranus has 13 rings and 27 moons. That's quite a lot. We're going to the competition with Jupiter and Saturn. It was quite surprising for astronomers because it's a gas giant and it's so far away, and the planet is on its sides. However, most of these rings are not exactly in the plane of the Uranus equator, and most of them are not exactly circular. And they're quite different that, for example, for the Jupiter rings, these Uranus rings comprise mostly of microscopic particles of water, ice, and unknown material, not dust. We know it's not dust. And that's make these rings very dark, not for the other planet, for example, like Saturn, and the brightness of them vary depending on the angle of the ring. And usually we classify 3 types, different groups of the rings. 9 main ones are very narrow: 6, 5, 4, alpha, beta, eta, gamma, delta, and epsilon. The 2 dustier rings are in their own group, zeta and lambda. The 2 outer rings are nu and mu, and the brightest and densest ring of the whole system is epsilon. It's also the most eccentric, with a thickness that varies from 19.7 kilometers to 96.4 kilometers. So it varies from the circle by that. And another interesting and unique feature for this, all the rings, that they're all very young. Scientists suggested about 600 million years old, which is quite young in comparison with the age of this planet. What does it mean for us? It means that they must be replenished by things like collision of large particles, moons, or meteorites. This also, we're observing the Shepherd satellites, the moons. For example, for Epsilon, there are 2 of them, Cordelia and Ophelia. They confine it and divide its inner and outer edges. We talked about this about the Saturn rings as well, a little bit about these shepherds. However, we don't know how the other rings that doesn't have shepherd satellites maintain their shape and not spread out. It might mean that there's more moons which we didn't observe yet. Of all the 27 moons are named after characters from the writing of either Alexander Pope or William Shakespeare, as you noted. First ones to be discovered were Titania and Oberon, and they've been seen by William Herschel himself. The most recent discoveries, such as Cupid and Francisca, were made using the Hubble Space Telescope in 2003. They're not very massive, despite the number, and for example, if we take the most massive 5 ones, they will combine the less than half of the mass of the Triton, the Neptune's larger moon. So the largest ones are Miranda, Ariel, Umbriel, Titania, and Oberon, and the largest of these is Titania, with a radius of 789 kilometers. That's not much. All of these moons reach the hydrostatic equilibrium, so they have enough gravity to keep them spherical. So whatever collision happened and whatever time they formed or after crashing into each other, they took those spherical forms due to the gravity and rotation with time. And one of them, Miranda, is primarily ice planet, ice moon. Other ones seems to be balanced between rocks and ice equally, so half of the moon is rock and half is ice. The largest ones suggested to maybe have even differentiated interiors with the cores and mantles. We see that mostly they're heavily cratered from the impacts with meteors and other objects, probably other moons in the system. And except of Umbriel, they all suggest that they have geological activity on them. Inside of Miranda's orbit lie 30 inner moons, and they're all associated with one ring. And scientists know very few about them. The largest one, which was imaged by Voyager 2, named Puck, is about 162 km in diameter. They're very unstable orbits, and some suggested the gravity affecting them and the movement, so they from time to time might collide to each other. The 9 irregular moons orbit very far away from Uranus compared to other moons. And probably they were captured by the planet, by its gravitational pull, soon after the planet was formed. They all have eccentric orbits, and all but one, Margaret, are retrograde. It means that they orbit in the opposite direction of the planet. And scientists suggested there must be more moons which we didn't observe, the ones we didn't discover yet. So here we go, this is the very unique jewel of our solar system. It's a gas giant, but although it has a lot of treasures inside, it has a lot of rings and the moons I bet you didn't know about before. It has very unusual axis and rotation around our sun, which today we can only explain by some kind of collision. So little we do know about these distant planets, and from just one flyby more than 30 years ago, we cannot recreate the picture of what actually happened with these icy giants, how they were formed, what caused this particular condition on them, and maybe what events caused the peculiar features on Uranus we're observing now. Why it's important to understand such a distant world, you will ask me. It is all important because the more and more researchers now looking for the planets on the distant stars around our universe, and the more we see that the majority of the stars which observing having planets of types of like Uranus and Neptune, and it appears to be the very common type. It means that mid-size gazy planets are a basic ingredient of the universe we live in. We have a small window of opportunity to revisit Uranus in 2020s and early 2030s, when the planets will be in particular arrangements, so the slight shot around Jupiter would boost a probe to Neptune within 6 years. If we miss this opportunity, next time it will be only after 2050. For a long time, there was no conversation about coming back to Uranus. It seems like not important, not interesting. And today, when we landed on Venus, rover the Mars all around, step on the moon, and study in detail satellites of the Jupiter, Saturn, Uranus and Neptune will be the next planets to explore. NASA and European Space Agency have been looking for the missions to learn about these giants. And there's a high priority to study it in the future. We can answer the big questions about these planets. Why Uranus so peculiar? Why it's so similar to the Neptune and at the same time so different? Why there is such a cold temperatures on Uranus in comparison with other planets? What's happened with it? Why it's spinning differently? And there are more moons in rings around Uranus in what they tell us about the planet, its evolution and history. And a very interesting question about the magnetic field of Uranus. And overall, we will more understand why the planets like Uranus and Neptune exist today. Theoretically, there was not enough material hanging around for them to form where they are today, in the beginning of the solar system life. And today we have some kind of explanation, for example, nice model suggesting that the ice giants were born closer to the Sun in the beginning, and then they grew quickly in the dense dust and gas there before they migrate into the current position, to the current orbit today. Enormous amount of information we get from probing the ice giants, getting samples and scanning from the close distance. Therefore, there's so much to research in our own home, our own solar system yet. I hope you liked this video. Please follow me, share this video with anyone who might be interested, and I'll see you in the next video.